Acceleration positive, no, this has to be increased. Velocity has to be increased. Yeah, it's increasing, so velocity is positive. Like it could be from here going up, right? The acceleration would be positive.
He's saying that velocity has to be positive for acceleration to be positive. No, it only has to be increased.
I think you're getting speed and velocity. Alright, so here we go. So we're gonna move on and we're gonna start these notes.
For us, only one of us.
You guys are coming out of my video, taking my limelight here. Alright, so anyways, we're gonna move a little bit more with particle motion today. And we're gonna eventually get to the topic of finding net distance and total distance. On the AP exams, they really don't use the word net distance, but they could. They call it displacement. Have you ever heard of that word? Displacement? What's displacement?
It's a change in the shortest distance.
The distance from where you originally started to where you what ended. That distance is the displacement, right? Total distance is just how much you traveled, right? In total, it doesn't matter in which direction you move. You just add up all those distances and you're good. So we're gonna get to that eventually. For now, let's practice. Let's look at these questions, and I'm pretty sure we're gonna get into some interesting conversations here. So the graph below represents velocity, v of t, which is measured in meters per second of a particle moving along the x-axis. So this is the what graph? The velocity graph in meters per what? Per second. So this is already a rate. The first question says, at what values of t does the particle have no acceleration on the interval 0 to 10? Where would it have no acceleration? From 3 to 6?
Yeah.
No acceleration, what does that mean?
Velocity is constant.
Velocity is constant?
No.
Wait. No, velocity is constant. Yes, velocity is constant.
What if velocity
What is
changes?
acceleration?
Can also be at 1.
So that's a change in velocity.
Which is, but it has to be 0.
So would it have no acceleration at 1?
Yeah. Fuck you.
Hey, the recording man.
I know.
Acceleration is the derivative of velocity, right?
Yeah.
So it would be like, if you say no acceleration, then velocity has to equal to what? 0? Well, what about if it was undefined? So is there acceleration here or no acceleration? No acceleration?
But didn't it like
What happened here at 1? Did it change direction? No, velocity is still what? Still positive, right? So still moving in the same direction.
But the acceleration turned negative.
But the acceleration turned negative?
Yeah, there's still
Oh, yeah,
acceleration.
so the acceleration is 0.
So in order for the acceleration to change from positive to negative, did it have to be 0 at some point?
Yeah. Yes.
But like, yeah, but like.
Does IBT guarantee a value?
just see?
No, yeah, it has
Has to? Momentarily?
Yeah, I feel like it's.
It just says has no acceleration. It didn't say the acceleration is 0.
Yeah.
So would undefined also be good?
Yeah.
So what should we write? The particle has no acceleration at what? Has no acceleration or as Alejandro said, infinite acceleration? What would we say then?
At one.
You wanna say 1?
Yeah, because you're saying.
Okay, so at t equals 1. Where else? 3 to 6, right?
Yep.
Acceleration would be what? 0, right? Is 3 and 6 included?
Yeah.
Yeah, if you're including one, then you have to include three.
Yeah, okay. That's what Anthony said. So you want me to put like brackets, 3 to 6?
Yeah.
Okay. Where else? And 8. And what would be your justification? Because
B prime of three is
Changes from.
v prime of t
Oh, well,
No, it wouldn't be.
equals
Zero
0 or undefined? So that would be describing it using the derivative, right? If we describe it using this graph, then it would be because what?
Increasing and decreasing.
It changes from what?
Increasing and decreasing.
Increasing to decreasing, or it what? Remain constant. Cool. So we could say v of t changes from increasing to decreasing, or vice versa. Or v of t is what? Constant? Cool. That's a good question. Well, we'll have to ask the physicists about that. See what they think. If we get a chance, ask Mr. Paulson. See what he'll say. I think there's a difference when the question says when is the acceleration equal to 0 and when is there no acceleration. That would be two different questions. Okay? Yeah?
They'll put it for
Alright, so let's look at this one. Express the acceleration as a piecewise defined function on the interval. So how would I find the acceleration function if I knew the velocity function? What would I have to pay attention to? The what? Starts with an S.
slow.
The slopes of the what?
Yeah, the velocity function.
What would be the slopes of the tangent lines on the velocity graph, right? It just so happens that the velocity graph is made up of a whole bunch of linear pieces, right? So if I drew tangent lines anywhere in those little intervals, they would all have the same slope for that entire interval, right? So that means the acceleration would always be the same in that particular interval for each of those pieces, right? So I have to write a different equation for each one, and they're gonna end up being just values. Because the acceleration from 0 to 1 will always be the same. Doesn't matter where I draw a tangent line there, they'll always have the same slope, right? So what is the slope from 0 to 1? 3? So that's actually the equation of the acceleration in that particular interval. Okay, so it's gonna be 3 on the interval from 0 to what? To 1. We're not gonna include the input. Then the next one will be what? If I draw a tangent line anywhere here. -3?
Yes, sir.
Okay. So -3, and that'll be from 1 all the way to what? To 3. And then what would the acceleration be from 3 to 6? 0, right? If I drew tangent lines anywhere there. How about on the next part, from 6 to 8?
Positive.
+3? Very good. And how about the last one? -3/2? That is from 8 all the way to what, 10? we came up with a piecewise function that represents the acceleration on the different intervals for this particular graph. So if I ask her, what is the acceleration at 7, what would you tell me? 3? Okay, what is the acceleration at 0.5? 3. What is the acceleration at 1.5? -3. What is the acceleration at 9? -3/2. Very easy. Okay, you're looking at the slopes of the tangent lines of that interval. Alright, the last two questions so we can be done with this. For what values of t is the particle moving to the right and moving to the left? Justify your answer. So, velocity function, we're going to look at it as positives, zeros, and negatives, right? So when would it be moving to the right? From 0 to what? 2 in union with 7 to 10. Because v of t is greater than 0, right? The velocity is greater than 0. When would it be moving to the left?
From 2 to 7.
Only from 2 to 7?
Yeah.
And that would be because velocity is less than 0. Too easy? Alright. Find the average acceleration of the particle on the interval from 1 to 8. Average acceleration. So what does that mean? That's a rock of who? Of velocity, right? So if I wanted to write the formula, I'm not going to use a's in it, I'm going to use velocity, right? So here my average acceleration is going to be v of what? 8 minus v of 1 divided by 8 minus 1. So isn't it just 0? Let's see. That would be like me going to my graph up here, Kristen, and drawing a secant line from the point 1,3 to the point 8,3. And if I drew a secant line, what would the slope of that secant line be? 0, right? And that's what I should get when I work out my formula down there. Right? Is that what I get? 3 minus 3/7, you get 0. So on average in that time interval, was the particle accelerating or not? No, on average, right? Why do you think that happened? They canceled each other out, right? Like he accelerated and then he decelerated, right? So it balanced out, right? On average, he wasn't accelerating in that time. And what would be the units?
Just saying accelerating
Meters per second squared.
Good.
Good.
Yeah,
Too easy?
you can slow down.
We still have time? 9 minutes? That's too much time, we gotta keep going.
Oh, we're good. That's actually. So you won't go over like something.
I won't go over something new?
Gabriel has a point.
Okay. Are you sure we can't do the definition? No.
And my partner.
I think we can do the definition. What do you think?
Hey, when are we doing tomorrow, sir?
Come on, this is true, right? Come on, guys.
Zoom tomorrow.
Let's do the definition.
Let's take a vote.
Ready? Alright, so here's the new stuff. Definition of net distance and definition of total distance. What do we say another word for net distance was? Displacement, okay? That's how they're gonna ask it on the AP test, but they could say net distance, so just be careful. Don't freak out if they use it. What do we say this was? This was the distance, right? Between what? The starting point and the end. The distance from where it was that you started to where it was that you ended. That's it. Doesn't matter what you do in the middle. Doesn't matter that you went forwards, backwards, up, down. From where you were when you started to where you were from your end. Easy? Alright, how about total distance? Total amount you traveled. So could we say that it's the sum, right? of all the distances. Right? The sum of all the distances moved in any direction. It doesn't matter which way you were moving, you're adding that distance that you traveled in that direction. Right? Just because the car is going in reverse, doesn't mean that the number of miles start coming off on my car?
No, they didn't. I actually didn't hear you.
Okay, so what is the odometer telling me?
What's the dog you can see?
The total distance traveled, right? It's not giving me the net distance, right?
Put it
Or
in
the
reverse
distance.
and see if it goes good.
Oh,
Very good.
that would be cool, right? Alright, so one last thing before we finish, we still have time. So let's see if you can answer this question.
Let's go.
If a particle is moving in the same direction the entire amount of time, what can be said about the net distance, which is the displacement, and the total?
Equal to each
They're
other.
equal?
Yes.
Why?
Because.
So I never changed direction, so that means
You're
where I started to where I ended, right? It's gonna be the same as the total distance, right? So the net distance will equal the